Hi friends, let's work out some mathematical problems using natural, rational and irrational numbers.
So let's first look at finding n rational numbers between two rational numbers, any given two numbers. Let's say we want to find six rational numbers between, for the first example, consider 3 and 8. For the second example, consider 3 by 4 and 7 by 4. And for the third example, consider 3 by 4 and 4 by 5. Okay. So for the first example, 3 and 8 can be written as 3 by 1 and 8 by 1, because by 1 to bring it in the P by Q form. Note that whenever you are trying to find rational numbers between two rational numbers, the denominators have to be the same. Just like when you are trying to add two rational numbers, denominators have to be the same, or subtract two rational numbers, denominator have to be the same. So now, since the denominators are already same, we know we need six rational numbers. A small typo there in the spelling of need, just excuse that. So we multiply the numerator and denominator by 7. So we get 3 into 7 divided by 1 into 7, that is 21 by 7. And 8 into 7 divided by 1 into 7, that is 56 by 7. Right? And now we can enumerate the six rational numbers between these two numbers very easily, because we have 21 by 7. The next rational number will be 22 by 7, then 23 by 7, then 24 by 7, 25 by 7, 26 by 7. Okay, and the final one will be 27 by 7. Okay, so these are the rational numbers, six of them between the given two numbers. Okay, so let's take the second case, 3 by 4 by and 7 by 4. Okay, in this case also denominators are same, so we don't need to do anything extra here. So again, we need six rational numbers, so we got to multiply the numerators and denominators by 7. So we get 3 into 7 divided by 4 into 7, that is 21 by 28. And 7 into 7, that's 49 by 28. Okay, so once we have this form, it is easy to enumerate the six rational numbers. We already got 21 by 28, so we start from 22 by 28, 23 by 28, 24 by 28, 25 by 28, 26 by 28, and finally 27 by 28. Okay, so these are the six rational numbers between the given numbers. So for the case 3 by 4 comma 4 by 5, you will notice that the denominators are not the same. So what you need to do is take the LCM of the denominators and make sure the fractions have the same denominator. Okay, so if we try to compute LCM for 4 and 5, we take the prime factors. 2 divides 4, again 2 divides 2, 5 is there, and again 5 is there, which divides 5, so you get 1 1. Finally you see that the LCM is 2 into 5, that's 20. Okay, so the first fraction, to make the denominator 20, we need to multiply it by 5. So numerator also gets multiplied by 5, right? So we get 3 into 5, 15 by 20. And for the second fraction, we need denominator to be 20, so it gets multiplied by 4, numerator and denominator. So there we get 16 by 20. Okay, so now you can see that we have converted the fractions to common denominator. Now again we need six rational numbers. So what we do, we multiply both numerator and denominator by 7. Okay, so 15 into 7 in the numerator divided by 20 into 7, and 16 into 7 in the numerator divided by 20 into 7 in the denominator. So that gives us 105 by 140 and 112 by 140. And we can now immediately write down the rational numbers between these two fractions. So we start with 106, right? 106 by 140, and the other one would be 107 by 140. Next one would be 108 by 140. Okay, next one would be 109 by 140. Next one 110 by 140, and finally 111 by 140. Okay, so these are the rational numbers between the rational numbers which were given to us. Okay, so the next way is next set of problems. We want to convert our decimal numbers into rational numbers. Okay, suppose I am given a decimal number. Let's say let's take the first case of 0.47 recurring, where only 7 is recurring. Okay, so if we call it x, it will be 0.4777 repeating, right? We do 10x, that will give us 4.777 ... Okay, now 10x we can write it as 4.3 plus 0.477 repeating, right? So you can see that the 0.477 recurring is nothing but x itself. Okay, so we can write 10x as 4.3 plus x, which means 10x minus x is equal to 4.3, right? 9x is equal to 4.3. So x is equal to 4.3 divided by 9, that is equal to, to bring it to the p by q form, you multiply both numerator and denominator by 10, you will get 43 by 90. Okay, so this is how we converted decimal into rational number. So taking the second case, if we have x is equal to 0.6 recurring, which is 0.666, when we do 10x, this is an easy case, we get 6.666, which we can write as 6 plus 0.666, right? Then again the same technique, replace the continuing recurring number by x itself. That gives us 10x minus x is 6 and 9x is 6, therefore x is 6 by 3. Okay, but 3 2s are 6 and 3 3s are 9, so we can simplify it to 2 by 3. Okay, so let us take on the next problem, the third problem, in converting decimals to rational. So suppose x is now 1.27 recurring, that is 1.272727 etc. Now there are two decimal places recurring, so we multiply by 100 and we make it as 100x is equal to 1.27.2727 etc. Okay, if we write this as 127 plus 0.2727, we cannot replace this 0.2727 by x, because it is 1.277, right? So what we do is, instead of 127 plus something, we write it as 126 plus 1.277, so that we are able to replace this repeating decimal number by its x value. Okay, now again we get 100 minus x, 100x minus x is equal to 126, 99 x is equal to 126, and x is equal to 126 by 99. Okay, now let's take one more case. Let's take x is equal to 0.001 recurring, which means there are three decimal places which are recurring. Okay, so x is, so we do 1000x here, because see 0.001001 it's going like that. So 1000x will give us 1.001001 recurring, right? So 1000x is equal to, we can easily write it as 1 plus 0.001001 and etc. Okay, and you can notice that we can replace that by x itself. So 1000x is equal to 1 plus x, 1000x minus x is equal to 1, 999x is equal to 1, therefore x is equal to 1 upon 999. Okay, so let's practice reverse, convert fractions into their decimal values, or convert rational numbers into their decimal values. easy case is just 36 by 100. Here what you do, you are dividing it by 100, so you can just bring in the decimal places of number of zeros basically. So if you have something like complicated like 4 1.8, you have to, it's a complex fraction, you have to represent it as 4 divided by 1 plus 1.8, and the LCM of the denominator is 8 itself, so we multiply numerator and denominator by 8, giving us 32 by 8 plus 1 by 8, so that gives us 33 by 8. Okay, so now we have it in desired fractional form. We do a simple division of 33 by 8, 8 4s are 32, you get a 1, then you put a dot, then you do 8 1s are 8, you get 2 as the remainder, 20, and 8 2s are 16, then you get 4 as the remainder, 40, and 8 5s are 40. So you do a simple division like this, and then you using this we have converted 33 by 8, that is 4 1 by 8 to 4.125. Okay, so what is 329 by 400? So it is easy here also, you have two zeros which can cancel, you get 3.29 by 4. Okay, now then it's a simple division of 3.29 by 4. You put a 0 and you put a 8, 4 8s are 32, right? And 9 is the next number, so you pull it down, and 4 2s are 8, then 1 0, 4 2s are 8 again, 2 is the remainder, 20, 4 5s are 20. Okay, so this fraction is equal to 0.8225 in decimal. Let's simplify some rational expressions now. Okay, so this is the other set of problems. Let us say somebody gives you 3 plus root 7 plus, multiplied by 2 plus root 5. Okay, so using the 2 we multiply both 3 and root 7, so we get 3 into 2 plus 2 into root 7, then root 5 into 3 root 5, and root 7 into root 5, right? So this is a distribution of multiplication done in previous classes. 3 2s are 6, then 2 root 7, then we have 3 root 5, and 7 5s are 35, so we bring it into the square root. Okay, so if we somebody gives us root 3 plus root 7 whole squared, we remember a plus b whole squared formula, which is a squared plus b squared plus 2ab. So you get root 3 whole squared plus root 7 whole squared plus 2 root 3 root 7, because root 3 is in the place of a, and root 7 is in the place of b. So root 3 whole squared is nothing but 3, root 7 whole squared is nothing but 7, 3 plus 7 is 10, so we get 10 plus 2 root 21. Okay, so 11 root 11 plus root 7 and multiplied by root 11 minus root 7. Remember the formulas again, a plus b into a minus b is a squared minus b squared. So in the place of a is root 11, so we put root 11 whole squared, and in the place of b is root 7 whole squared. So root 11 whole squared is nothing but 11, and 7, you get 7, 11 minus 7 is 4.